sound balance, and so much more is getting clearer all the time. All we see are all these dead straight lines, and show me what's in reality, and I won't compromise between the truth and lies. This is where I make my stand. Please don't take me to your la-la land. It's all about geometry. All we see is horizontally. Show me what's in reality, and I won't compromise between the truth and lies. Show me what's in reality, and I won't compromise between the truth and lies. Reality is all I see. I don't need your fantasy. I've had enough of sophistry. I'll find my own philosophy. Reality is all I see. I don't need your fantasy. I've had enough of sophistry. I'll find my own philosophy, and you can't bend reality into what you think your card deceives. Something's happening to me. Don't remind me of how things used to be. We don't need no sycophants. Aren't we all just so sick of that?
And we are live. Welcome everyone. It is it's a Euclid day, but today is Descartes' birthday. So sort of doing a little bit of a special Descartes. Famous for a mathematician, obviously. He did go mad. It is at about that sort of time, 1637, I think he might. I don't know whether that was when he was born or when he died. Or, yeah, I don't know. But around that sort of time, really troublesome times about bacon. So they did Cartesian coordinates, obviously. Everybody knows what that is. I'm going to be doing a little bit of geometry a bit later on. I'm calling it blue marbles proof. Blue marble science. He's have to be blue marble science. He's decided to use proposition 29. So we're going to be going over that, obviously. But one of our maestros, Kevin, wants to be part of it, obviously, as everybody does. So we've got to waffle on for a little bit. Perhaps about 3/4 of an hour. That's all right with everyone. Whoa, what? Moderator turned on subscribers only mode. Oh, did you do that, Emma? Thank you.
I did, yeah.
How can I not do it, but you can? I've given Emma the power. Look at that.
You erased everything.
Amazing. Well done. Thank you very much. We've been
Great
trying to do
research.
that for ages. So much better. So, things are changing a bit, obviously. Subscribers only mode on now, so the chat should be free for people to have active, lively discussions about the sort of things that we're talking about in the chat. This channel is mainly based around logic, geometry, but obviously because it's based in logic, then that applies to just about everything, really. So that's what we're doing. There's not much logic in contradictions, right? But there's plenty of logic in spotting contradictions, which is what we tend to do mainly. There's a big raging debate going on at the minute, and that's between the dogmatics of the blue marble scientists and the sort of reality understanding, and it's based around a straight line. Simple as that. Now, all sorts of different ways that everybody deals with the straight line issue. We sort of build these arguments, obviously, but it's because we're talking about straight lines. We are primarily really talking about geometry, and people would know what a straight line is through knowing about certain shapes, right? Well, a circle obviously has a curved line, but the radius is straight, has to be straight for you to have the circle. Triangles, squares, hexagons, all of the shapes apart from a circle and ovals and stuff like that. The ones with straight lines, they're the ones with straight lines. They're called polygons in simple geometry. And that's what we're talking about here primarily, just that straight line. Now, because you need that straight line to make ellipses and circles and spheres, and the straight line always exists in reality. Your understanding of right angles, squares, triangles, trigonometry, all of that, we're talking about straight lines. Now, these straight lines have geometric principles around them based around the shortest distance from A to B. Actual straight lines, geometrically, they exist in this realm called like a mathematical realm. It is. Plato called it the ideal realm. So you're always trying to find perfection. That's where perfection exists, in this mathematical realm. The ideal scenario that you can go to in your imagination to understand principles in reality. Now, obviously, there's mistakes and things that happen in reality, slight imperfections. You can never have the perfect scenario like you can in the mathematical realm, but you try and get it as close as possible in reality. That's the idea of bringing geometry into reality. I mean, the idea of geometry is breaking down into the geo, which is an old word for earth, and back then earth was just like the land, the ground, and the measurement, the metra. The geometry is the measurement of the land measurer. So all of the principles that you use in geometry exist in reality for you to be able to measure things in reality. Triangles, squares, and the like. The construction of which uses a radius, a straight line, but fixed about a point. Well, that shape's called a circle, and we use that moving of the radius in order for you to be able to tell certain things. Now, there are, I call it tricks, but these aren't tricks. These are principles of what you can tell from the having these 2 points in space, and you being able to manipulate one point relative to the other point. So this is where I guess the foundations of relativity comes from, because in order for you to be able to compare anything, and this goes with the words as well, you have to know what you're starting with to be able to compare something to that. Well, the straight line and the distance between the straight line being in between these 2 points makes you able to make a judgment on one point relative to the other. That's the straight line. And then you can manipulate them and move them around and do some like fantastic, call it trickery, but it's definitely not trickery. It's logic. It's something that you can do naturally. It's not really taught within the mathematical structure in schools anymore, this basic fundamental thing, because it develops a logical process within the brain that you aim to carry on these arguments moves over into the into reality. You can learn how to formulate the arguments, the perfect arguments within the mathematical realm, mathematically, logically, and then you can implement that understanding into reality, either within the construction of like buildings and all of that sort of stuff, or you can try and make the arguments as close to this as you can, so you know how to formulate arguments, and for you to be able to have, call it the rhetoric, but I mean, a rhetoric's a bit of a really weird word, just for you to know how to be able to describe things, and the understanding that you can demonstrate these ideas. It's sort of a way that, I don't know, that you can help people understand the idea as well, geometrically. So, we are the debate that's going on at the minute. Not see it's much of a debate, but the thing about the straight line, I never thought I'd ever come into an arena and have the idea where somebody would try and, I call it gaslighting, because it is definitely gaslighting, to make you possibly think that you don't actually understand what a straight line is, a square, triangle, how they're formed, what they are, the relationships of the sides to each other. Somebody's trying to tell you that that's not true. It's not real. Well, a straight line is a fundamental. So for anybody to say not that, they're sort of showing you exactly how sophisticated they're attempting to be. Because everybody knows what a straight line is. And for anybody to tell you that you don't know what a straight line is, they're either insane or they're purposely trying to gaslight you, which I consider one of the weirdest things. Because obviously somebody would go for it, right? If you imagine you're giving somebody authority and that they are then telling you that you don't know what straight lines are within an arena where you're meant to be having a conversation, debating an argument. Hello, Rob. Good day.
I even have an abbreviation for that kind of people, GTA, not the game, computer game, but Global Troll Association.
GTA RP.
So it's just the idea that somebody could do that is beyond it's beyond a joke to me, because they are literally trying to do that to us at the minute. I'm an adult. I know what's going on. But this guy that's trying to do that, saying he's doing it to kids, to children. He's saying he's a teacher. That puts him in a position of authority. It's not as if the school kids can be like we were. But what if they were? I don't understand, sir. What are you telling me about straight lines? Basic fundamentals of logic, I think. You go back to it, the law of identity, the excluded middle, law of non-contradiction, and most importantly, sufficient cause. Why would somebody tell you that straight is slightly different? For what purpose? What reason would make somebody do that? Because there's a lot of people that are coming in who've been in the Discord for a bit today, trying to do similar sort of things. I don't know what it's about. To say that you understand reality, north, south, east, west, like, where's there any space for anything else? That's right angles. They're perpendicular. North, south, straight line. East, west, straight line. These two lines are perpendicular to each other. You can see it on a compass. It just gets a little bit tricky when you try and add in a dogmatic model. It's great to see that subscribers only mode there, Emma. Thank you very much. Should make the modding a lot easier. Remember, that's only people to be able to chat in the chat. Oh, so good. Right, are you back, Kevin? Are you done? You around?
Yes, sir, I am.
Jolly good. So, should we go over the blue marble proof, or should we just go over the argument first? Because let me...
Yes, let's go over the argument first for sure.
Okay, right now, share my screen. This is what's going on? Let me just sort this screen out here. There you go. Okay, so this is blue marble science, and he did a video, reciprocal zenith angles, and this is what Blue Marble is claiming to falsify Proposition 29. I think that's the way he does it. He's using Proposition 29 and falsifying Proposition 29, but we'll get round to that in a bit. We'll go over the geometry of it. This is what Blue's claiming. So let's see if you can hear this.
It's 90 degrees, and if you're looking further down,
Let me just get this bit, yeah.
two zeniths ever be parallel. And measuring reciprocal zenith angles can show this.
Okay.
Well, what is a zenith angle? And I'll read you a definition of it. Vertical angle, also known as zenith angle, is the angle measured from directly above the zenith, so perfectly horizontal, will have a vertical angle of 90 degrees, like you see there. If you're looking to a somewhat higher elevation, the vertical angle will be less than 90 degrees, and if you're looking further down, it will be greater than 90 degrees. So let's look at this interesting little diagram. If the zeniths were parallel, there's one, there's another zenith parallel to it. If we cut those two zeniths with a line like that, these two angles have to equal 180 degrees. We can prove that with Euclidean geometry, no problem. And it doesn't matter what line we cut those two zeniths with, the sum of the two angles still always has to be 180 degrees.
Right, he's saying we can prove it, but I don't think he does. Like we'll have a go at doing that. Hopefully, he might have a go tomorrow with flat Earth math. But he just states it here. We can prove it. Like we can, definitely, yes. And we'll do our best to show you. Don't think he does.
Hey,
He
Bev,
just
can
states
you
it. Sorry.
can you go back? Can you go back maybe a minute and a half? Because I think I heard Blue say something, but I don't want to say it. Back to where he talks about the definition.
Yeah.
In reality,
Oh, we've got this loads here that Blue's done.
this
No,
is
no.
a GPS
Yeah,
data
yeah.
taken
Yeah.
from
I was thinking right where the definition was. Where he talks
Parallel.
about the
Then 90
definition is
degrees.
right there. Yeah, just
So let's
before
look
that.
at this interesting.
Before he brings up those diagrams. Yep, we'll go right there. That's good.
What is a zenith angle? And I'll read you a definition of it. Vertical angle, also known as zenith angle, is the angle measured from directly above the zenith, so perfectly horizontal, will have a vertical angle of 90 degrees, like you see there. If you're looking to a somewhat higher elevation, the vertical
Pause it.
angle will be less than 90.
Okay.
Did he say elevation?
Yeah, if you're looking from a higher elevation.
And then he says a lower elevation.
Okay, let's have a look. Go over that again.
Horizontal will have a vertical angle of 90 degrees, like you see there. If you're looking to a somewhat higher elevation,
If you're looking to a somewhat higher elevation, somewhat.
Mm-hmm. Somewhat higher.
Yeah.
Okay. Elevation,
The
though, still.
Yeah,
Yep.
absolutely, yes.
vertical angle will be less than 90 degrees, and if you're looking further down, it will be greater.
If you're looking further down. So further down is opposed to a somewhat higher elevation. Because he's got horizontal,
Mm-hmm.
somewhat higher elevation,
Yes.
and looking down.
Be careful with higher.
Yeah,
right?
I know, yeah. It's
Flat Earth math said,
It's
remember?
got math coming round on Friday, yes.
Mm-hmm.
And
Yep.
down, I'm not too sure about looking down.
Down.
No.
Mm-hmm.
Yeah. Okay, so yeah, definitely seems to have an incline or a decline. That's what he's
Right.
talking about, yeah.
Okay,
And then
great.
90
Thank you.
degrees. So let's look at this interesting little diagram. If the zeniths were parallel, there's one, there's another zenith parallel to it. If we cut those two zeniths with a line like that, these two angles have to equal 180 degrees. We can prove that with Euclidean geometry, no problem.
So cutting the zeniths with a line like that is how we do this.
And it doesn't matter what line we cut those two zeniths with, the sum of the two angles still always has to be 180 degrees.
Parallel.
What happens for diverging zeniths? There's two zeniths that are not parallel with each other. Let's cut them with a line, and now the sum of those two angles has to be greater than 180 degrees. And again, it doesn't matter the orientation of that line. The sum of the two angles is always greater than 180 degrees if the zeniths are diverging as we're showing here.
Anybody
Well,
see
can we
anything there? Can
measure
you pause
this?
it?
Yep. You wanna
Anybody
let it go
see
back?
anything in those diagrams? Anybody notice anything about those two diagrams as it relates to 180 degrees? What has Bev said about 180 degrees?
Two right angles.
Hmm?
Two right angles.
And
Or a
also,
straight line.
yeah. What else? What else has 180 degrees? Come on now.
Straight line. Okay.
Triangle.
Okay. What else? Triangle.
Yeah.
Triangle. Anybody see a triangle there? Either one of those two?
You can here, like you can put a line across there, right?
Yeah, but it's not there.
But you can, like point to point.
Yeah,
That you would make
absolutely.
two triangles, and these triangles
Mhm.
would have 180 degrees.
They absolutely would.
Okay.
They absolutely would.
So
Yes, indeed.
although this may not be 180, if you were to make a triangle, both of the triangles would definitely have 180. So we'll get around to that in a bit, I think. Where I think Blue's made a mistake.
Okay, go ahead.
Okay.
Or diverging as we're showing here.
Just so we know the argument.
Well, can we measure this? Absolutely we can.
Can we measure it? Yes, we can. Like Blue says, it's in reality. Of course we can measure it. Definitely.
We only need to know two things. We need to know two fixed points that we can see and identify.
Okay. And he's got another 2 points here as well. 4 points, really, that is.
And we need a way to measure those angles.
And we know 4 points, really, because we know the elevation, don't we, of these. So we know the point that the little tangents are.
We can make that measurement with a theodolite. Now, a theodolite is a precision instrument for measuring vertical and horizontal angles, and professional theodolites make those measurements to a very high level of accuracy.
You know, professional theodolites. They're just theodolites, aren't they?
I don't know. Are there ones marked? This is a professional theodolite, and this one is for your desktop or something?
There's better quality theodolites, right? But the actual surveyor would be the professional, right? The person earning the money for doing a job, that's a professional, right?
Absolutely.
You can't really say the tools are professional. Tools could be used by the professional, which obviously would be better if they were of higher quality and better standards, but I'm not so sure. You don't get toy theodolites, do you? Amateur theodolites. I'm not too sure. But I mean, it definitely sounds better, doesn't it? If you say professional theodolites.
Yeah, it gives it an air of authority, a bit of an air of authority, sure.
Just pointing two theodolites at each other is obviously not as good as if they're two professional theodolites pointing at each other.
Well, I myself would say pointing two theodolites at each other is not professional at all. But
well,
okay,
yeah, I think that's what we're going to do, though.
And regardless whether it's an old one like this Wild T3,
matter of age,
or
as
a
long
more
as it's
modern
professional.
theodolite like the Trimble S7 you see there, both are referenced to gravity. So the theodolite's vertical reference is the gravity vector. That is your zenith.
Can you guys see the bottom of this corner here? This one's got copyright Blue Marble Science. It's copyrighting it.
So how do we do this? Well, it's pretty simple. We put one theodolite at one position, a second theodolite at another position, and we simply point the two theodolites at each other.
See, this is copyrighted Blue Marble science. Theodolite
that.
pointing at each other. It's been copywritten by Blue Marble science. Don't think it's anybody else's, right? Copyright Blue Marble Science 2022. Theodolites pointing at each other on balls. I wouldn't like to be this guy setting this theodolite up over here on the side of a ball. This one's tricky enough.
Copyright is something you do for your own intellectual property, right?
I would have thought so, yeah.
Yeah, so this is just Blue Marble stuff.
Yeah, they pointing theodolites at each other.
Yeah.
Right, yeah. It's not like a surveying technique or anything. If Blue Marble has to copyright it.
Mm-hmm.
Don't be thinking you can just go around taking Blue Marble's copywritten ideas of theodolites on balls.
And that'd go against copyright laws, wouldn't it?
It would do, yeah. So we are pointing out this is Blue Marble Science. Fair use. Does he have fair use on it? I hope so. Although it is copywritten. So we're not advising that you should, if you ever do attempt to point theodolites at each other, do realise copywritten Blue Marble Science.
And measure those two angles. That's all there is to it.
That's all there is to it.
Now, these measurements have been made untold thousands of times. But I'm going to talk about just a few specific ones. In 2018...
Okay, so basically, you get the idea, right? You point theodolite, you're just measuring angles. So everybody all right with that? We're going to have a go at doing this. Oh. No. Oh, I think it might be that one. This one there. Look at that. Right, so we're going to have a go at doing this. Well, seeing it is Cartesian 80 grid lines. So here we go. Descartes' birthday. We shall be using, in honor of Descartes, the Cartesian coordinate system as we're doing this. Okay, so in honor of Descartes, here we go. So this one's for you. So we'll go from 3 to 3. So we've got 2 points. We're doing the geometry side of this. So this is how we work geometry. From A to B, and then we have well, let's put a line on here. So we do have a line. That's what we're starting off with. Now, what are we doing? What are the other rules we're doing? Right, that's another point that we just have to put down. We are doing this by rules, okay? So what are the rules we're going to stick by? Obviously, since it's Descartes, in honor of Descartes and his birthday, we are going to be sticking to the Cartesian coordinate system, obviously. And anybody, any else? Like horizontal and vertical. Are we going to have any properties of that? They are perpendicular, right?
Definitely
Straight lines.
perpendicular. Yep.
Yep.
Straight lines.
Okay, so
Predates Descartes as well.
obviously.
Yeah.
He was obviously used them, right? So we've got 2 points, and Blue Marble has plumb, zenith, vertical, and what was the other one? Doesn't really matter. That's enough, right? Plumb, zenith, and vertical. They're all the same thing, and vertical is upright. So are we going to put, if I put a, how could we do that? Well, this line from A to B, straight line, we'll put all like a line all the way across it, right? So since we've already done the Vesica Pisces, is everyone all right with us putting the, obviously it's already there on the coordinate system, but if we put the use of Vesica Pisces as the perpendicular bisector of the straight line AB,
Yes.
so that's okay for everybody to get a grip on, right? So we've got, what we've got is we've got our original starting straight line from A to B, and we have a perpendicular bisector of that line right in the center of it. That's okay for our starting coordinates. It just so happens it fits perfectly with Descartes' system here called Cartesian coordinate system. Also, coincidentally, straight lines. Who'd have thought it?
Thank you, Descartes.
It's amazing, isn't it?
It is.
Right, so that's how we start off, right? Now, I mean, you can't really tell that I've actually drawn any lines on there. Very strange, that. So, what we need is, are we all right with horizontal being a line that goes from left to right across the page? Also, part of one of the axes of these coordinate systems. So is everybody all right with that?
Yes,
Yep.
zero slope from that center line. Yeah.
Okay, so that is basically this axis of this grid here. No,
Yep.
so if we want to do a perpendicular at A, which would be vertical, perpendicular line. What's this? Is this great? This. So you choose the line you want to be perpendicular to, and then you click on the point. Look at that. Right, so that's our starting point, A. And we've got a straight line that's at A. And should we put one at B as well? Perpendicular, because you would have your vertical at point B, wouldn't you?
Yes, indeed.
Okay, so this is what we're dealing with in reality. Now, let me just get this in. I don't know whether I can put them both together or not. But I'll just get this. Discord's changed the thing. Have you seen it? For pictures and putting stuff in, on at least on the iPhone anyway. It's changed it all. This one here. Put this in the Discord. This is proposition 29. I don't know whether I can upload a picture or not to put in the background.
If you figure out how to do that, please let me know. I've been wondering the same.
I'm pretty sure I saw it the other day. Global settings. Export image. Yeah, I'll find it. I will find it some other time, because I'm pretty sure I downloaded a load of stuff. Then you can put it back in the background, and I was hoping to use it. Okay, so we've got these now. It says if a straight line fall on two parallel straight lines, it makes the alternate angles equal to one another. So we see if the angle, this angle, and what's that? What's it doing that? Angle. This line. Oh, it may not. Yeah, but it won't add angles on the other side because it's obviously a right angle, and it keeps saying, "Don't be so stupid." But it's good. You've got 90 degrees there and 90 degrees there, so it says the opposite, the alternate angles equal to one another. So alternate would be not this one on the opposite. I call it opposite, but he does use the opposite angle as well. So which one are you going to say alternate angles are? Just so we show people. It says it makes the alternate angles equal to one another and the exterior angle equal to the interior and opposite angle on the same side. I can't really write on them. So you've got these angles, they're equal, aren't they? This opposite, obviously, because it's at 90 degrees. Can I draw another line to make them change? Line, right. Move. Okay. Now, did I? No. Because that's fixed to the circle. How do you move these lines? Don't suppose you can you? Let me go back. Anyone know how to do GeoGebra? So if I just draw a line here from there to there, and then get parallel line to that and put it there, then if I move, there you go. How's that? That's a little bit better, isn't it?
Yeah, that's good.
Okay, so now if I put this angle in here, from here to here, and from here to here, if I do move that, there you go. There you go. Look at that. So that works. Now, yeah, that's always going to be on that line, isn't it? Right, so the opposite angles, let me... I see the angle. Why are you not doing an angle? You don't have a line there. Oh, put a line in. Why is it not putting angles in there? I don't know why it's not adding an angle in.
Where do you want to see an angle?
Yeah, I want to see all of these angles so we can show the internal angles. Try it and shift. Yeah, it won't. I was doing it with the other angles. What about if I do that? That point. See, that won't do an angle there. Can I have point? Right, so angle A, G, A. And we're going to have a point up here, aren't we? Angle H. Right, so make sure everything moves. Yeah. So the angles. See, G's on the wrong line now, isn't it?
Yep, it sure is.
Yeah.
Yeah. Not really.
Yeah, that's why the corresponding angles aren't equal.
Yeah.
Sorry, the alternate angles, I should say.
It-
Yeah.
Hey Bev, can you change the fulcrum to point A? Because right now the the fulcrum points at point F. That's why it's not staying.
Oh, right.
Oh, yeah, yeah. Good catch. Yes.
How do you do that?
I don't know how you deselect and select, but maybe get
No.
rid of F.
Yeah, I have to go all the way back. I don't know why F's in there. Oh, is that because it was a straight line? Do the line from A to E and a line from B. No, because that needs to be parallel, doesn't it? Parallel line to that one there at B. There's no point F there now. So move that.
Gotta get that program and mess around on it.
So they are parallel, but I want later on. I'm going to want to not make them parallel, aren't I? Well, I tell you what. If I put a line from E to F, oh wait a minute. If I go back, I mean these are right. So first line goes from A to E, and then I can just do another line from here to here. And because we know that from E to F, put a segment in there from E to F. Move E. No. Oh. We'll get around to this in a bit. So how do we do I fix that top line? Get him to move on that top line? Because that's fixed there, isn't it?
Can't zoom in.
Right, let's have another line from there to there. And then if I do a line from there to there and have one parallel for now. Parallel from this one over here to this one. And then we're going to move this. Why is it not fixing that? It's because it's not at that point, isn't it? Right, I need E out the way. I need this line there to there. Now I'll have a line from here to there, and we'll have a parallel line from that one to there. Now, if I move that, that's good enough for starters. Right angle from here to here, and from here to here. And then we're going to go from here. No. Okay. So, let's start again. There you go. If a straight line fall on two parallel straight lines, which it is there, we've got this straight line and this straight line. It makes the alternate angles equal to one another and the exterior angle equal to the interior and opposite on the same side. So what we're talking about here is these angles here. Because this angle and this angle both add up to 180 on this straight line, this one does exactly the same because the lines are similar. The angles are similar, so these parallel lines cut this one exactly the same. And obviously on the opposite side, this angle here on this opposite side is the same as this one. This one right here is the same as this one. This one here is also the same as this one here. And this one here is the same as this one here. This one here, same as this one here. That's fine. And it works with this, these angles as though it is... why is that even on the... But when you place them in this position... No. If you can. 90 degrees, right angle. All of these are right angles. So every time you say if a straight line fall on two parallel straight lines, it makes the alternate angles equal to one another and the exterior angle equal. So these are all equal, but it all makes two right angles. On this straight line, obviously, two right angles. On this straight line, two right angles. On this side, two right angles. On this side, two right angles. They're all 180 degrees. So this is Euclidean proposition 29. Now, Blue Marble states not that. So, how do we keep the rules that we're dealing with of horizontal and vertical being perpendicular and change this relationship that we've got here? Anyone, any ideas?
I think maybe I'm wrong, but I'm thinking you can't. You'd have to give up perpendicular.
Yes.
In order to change that so that this no longer, what you've just shown no longer applies or is not true. And Saragaki can work out the language for not true, right? Then you can't have parallel. Just can't.
So,
Or sorry, perpendicularity. You can't have perpendicularity.
and then we've got these ones here now. Right, so we've got this now. So what we can do is we can have the perpendicular line there and a perpendicular line there.
Mm-hmm. Yeah.
right now. So we still have we've got our angle measurer. This one to this one. Why is he putting it over there? Angle measurer. This one. Huh. This one to this one. They put them both in the same place. That's really weird, isn't it?
Mm-hmm.
Right. So now you can see we've got two lines that aren't parallel and they meet down here. But could you call this one vertical?
No.
On this one. The only real one that you could call vertical is the one that's still on the axis at the beginning.
Correct.
And there is a horizontal that coincides with this one. It does have a horizontal, but we can measure this angle here to here. Oh, why does it do that? It's on the underneath.
I know that angle measuring tool in GeoGebra is annoying.
It helps if you have another point, but I don't
Another
want to
point,
put
yeah.
another point on there in order to do that. Somebody else will be able to do it. So you do have an angle here, right? So this angle is more, obviously, because this one is 81. So you've got a little bit extra here. So you can measure more angles here. But this one here, that's still 90. This is a 90 degree here to this one. But this one's more than 90. So in order for you to have this relationship, you have to be able to measure, I don't know. That has to go down more again, doesn't it?
Well, for those HB and HA lines, you would have to continue them past the non-verticals. Because it is talking about the external angles
The
as well.
external angles of it as well, yeah. But that's the problem, isn't it? So does that go up there? We have to have lines there rather than
segments, yeah, I would say so.
So we've got these here now. Starting to get a little bit complicated, isn't it?
Mm-hmm. Yeah, a little busy.
So, but this angle from here to the old horizontal seems to have gained because you've got a tilt of the line that was parallel. You can see which lines, the parallel ones, are going straight up and down, obviously. And then now we've got a tilt. So is this where Jesse is? And is this where Larry is? Or is this where Jesse is now? Is like...
I actually think Jesse is at H personally, but I may be wrong.
But originally it was at B, wasn't he? Like the line was AB originally. So if we just halved the line and lifted Jesse up a bit, and now we've got Jesse measuring these angles. Or are we still sticking with the B? Because H is now up in the middle of the air, isn't it?
Yeah, that's definitely an elevation change for
tilted
the horizontal axis.
Tilted the vertical and sloped the horizontal on both A and B.
Well,
that's not
in reality, of course. Yeah,
no, but this is the only place. This is vertical, right? This place H here is the place where vertical and horizontal still apply to reality. Not here. at A or B. Yeah, that was our original position, wasn't it?
Yeah.
If we move this, see if I can. Whoop, there you go. Look at that. That's handy. There you go. So this is how we started off with perpendicular and horizontal and vertical being perpendicular with our original A and B. But now, in order for us to measure more than 180 degrees, what we have to do is we have to lift this middle point up here and measure the angle from here down, back down to the original horizontal from the tilted. So we've added this angle here on the side, this angle here on the side, and I suppose the halfway, would that be? You'd have to put that a parallel in, wouldn't you? Parallel line to that one at H. Move that. There you go.
Yeah, and both
So
of
that's
those
your
angles,
horizontal.
they correspond, don't they? Both of those angles on the left and right side of the H, that's bisected by the horizontal.
This angle here, let's see whether we can get that angle from here to here. No.
How annoying is that?
We have to work out which one. This way to this one. Oh, there you go.
There you go.
Right, move that. 12.8. And measure the angle from here to here.
There you go.
And just move that. No. There you go.
Just put it further up.
No, it won't let me go up further up.
Oh, wow.
There. Right, so that's that angle in there. 12.8. That little angle there is equal to this angle here. We've developed a load of similar triangles. There's another one here. This right angle triangle. Because of the relationship of the parallel lines in here, across this axis and these parallel lines, we are making right angle triangles with this, and all of these angles, in fact even this one down here,
Yeah, even there.
I was just going to say that.
There you go. So that's at the bottom. Move that. See, it's there. That's that little angle there, but because opposite angles are equal, all of these angles are the same. 12.8. All of these 12.8. All of the small bits of all of these triangles, all 12.8 degrees, or whatever they are whenever you move this.
Yep, they'll all be the same, equal.
So because of the relationship that we've got here on these lines, and because this line follows through, I think we're going to have to go here, aren't we? It's the only place you can go when you're measuring the angle down and the angle down. So let's pretend Jesse's on one side looking that way and Larry's on the other side looking the other way. Because you can't imagine that Larry's ear leant back, can you?
Well, you can imagine.
Ridiculous.
Yes.
Like blue marble tries to tell you that like A and B, they're both tilting. Well, there's a shortest distance between A and B, this straight line. I think blue's trying to say that he wants these horizontals up here.
I do believe that's what blue is saying, but I think it's also worth pointing out that the actual transversal between A and B is the horizontal axis of
There
the
you go.
graph.
That's the original horizontal that we've got, that were 90 degrees and right angles. That works fine. But if you want to try and do a Jesse and Larry and add more angles in, I mean, can you just sort of lift this up a bit? No. Can you lift this one up a bit? No. You can only lift this one up, which tilts those, right? And that's what blue marble wants. Blue marble wants a tilt of the plumb line. But obviously, you can't have a tilt of a plumb line. If you drop a plumb line from the top here, it'll come down here. It won't tilt. So the adding of the extra angles, I don't even know. Can we draw it? How would we? I don't know whether we can. How would we draw it again for the other one? I'd have to start again from the beginning, wouldn't we? Without doing any. Let's clear all. Don't save. Right, so we just have a segment A to B.
That's Jesse and Larry, is it?
Yeah. Yeah, Jesse at one place and Larry at another. Now, height above, yeah, let's make it fair, right? No, let's say that's your, elevations. Elevation C and D. So you've got a height, haven't you? Could you say that would be vertical? I don't know. Let's see. I'm going to have to move these in a bit, aren't we? Just some random points of elevation or whatever. Let's say this is the datum. CD is the datum that you're working on. Is that going to be a straight line? Let's not say that, because I don't know how blue's working it. So you've got a line from A to C, and you've got a line from B to D, right? Does that look good?
Yep.
And then I guess in order for us measuring angles, you can go from E to F, right? But along this now, because of the proposition that blue marble's done, we have to have the external angles on either side as well. So what have we got here? We've got angle measurer. So we go E, A, B, and we can go F, B, A. Look at that. And I'll move these angles over so you can see them. Can everyone see that?
Yep.
And then you do the...
I'm going to have to put points over here as well, aren't I? Point here,
Yeah, 2
point
points
here.
there, yeah.
Just so we can measure angles. And E, A, G. G. C. Okay, so we've got all of those angles now. We'll move all of those so we can see them all. All completely random, apart from the opposite sides are equal. This one and this one, this one and this one, this one and this one. Right? They are all equal. So all of the opposite sides are equal. But not, what does it say? And the exterior angle equal to the interior and opposite angle. So the interior angle isn't equal to the opposite here. So this doesn't apply to the opposite angles. So what it's saying is the proposition that Blue Marbles decided to choose. It says if a straight line fall on two parallel straight lines, it makes the alternate angles equal to one another and the exterior angle equal to the interior and opposite on the same side. So basically what it's saying is, although the opposite angles are equal on both of these, the exterior isn't equal to the opposite exterior, and the interiors aren't equal because obviously
they're not parallel,
right?
Not parallel.
Not parallel lines.
Correct.
But not too sure this helps Larry and Jesse, because let's say we've got another guy at G. Right, well, we've got do we have this as an equal? No, we can't even put that, can we? So we've just got another point, a random point over here. Let's see that. And now we're going to draw some lines on here. So this is Larry and his mates. Anyone see the problem?
The problem is that he's working on the two angles equaling 180 while ignoring the fact that all four angles on the same side of the transversal on both sides of the two straight lines he's working with will equal 360.
Mm-hmm. Yeah, if these two equal more, well, these two equal 180. And these two on this side being opposites also equal 180. These two equal 180 and these two equal 180. So if you add this one and this one, you can get more than 180, yes. That's definitely true. And if you add this one and this one, you get more than 180. But if you add all four of them together, you will get 360. Same is true on this side, always. But not too sure that's what Blue Marble Science wants and Flat Earth Math.
It is also true for angle GHE plus EAB and ABF plus FBH. Those four angles will also be 360. The four angles on the...
Always.
Yeah, always. There's no way around it.
I can add all of these angles in if we need to. similar, they'll always equal 180 because it's a straight line.
Mm-hmm. It doesn't matter the actual angle of inclination between the two straight lines. It'll be two right angles on the same side of it, or 360 taken all together. Every time.
And just because you can add this angle and this angle together doesn't mean that there cannot be parallel lines. So if this line is a straight line, you can have perpendiculars to it. So just because these lines aren't parallel doesn't mean you can't have the perpendicular to the straight line.
Oh, definitely.
So in order for us to, I might have to give away a secret here, right? In order for us to do this, what we do is we start off with a circle and we put a point on it. Have we got a... I'm pretty sure there was a tangent thing, but it's not called tangent, is it?
Oh yeah, it's a little
Oh,
bit
there's
further
a
up there. It is.
tangent. Is it? More. Oh. There it is. What? No. Intersect point. Tangents. Where's it? Select point or line, then circle. Oh, no. There you go. So we've got a tangent on there now. Now, if we draw a line, you see the way we have to construct this. So let's put Larry there. And where are we going to put Jesse? Can't put Jesse. Can we put Jesse on there? All right. Okay, let's put Jesse there. Now that's 90, isn't it? Yeah. Okay. Obviously, zenith over here. But we're going to need to show one of their mates. So we have... Can this guy, main surveyor, be over here on that one? Is he all right to be on that line? Measuring angles. Okay, so let's measure some angles then. B, C, E, C, F, E, C, B, D, B, and is that all right? Or do we need the bottom angles as well? Move those angles out of the way so we can see them. Okay, so we've got Larry and he's measuring 90. But you've got Jesse over here. He's measuring 101. So 90 plus 101 is definitely more than 180. But because we're using the other angles as well, this relationship doesn't work. You know, the equal, but we're on a straight line. So this 180 degrees always applies, doesn't it?
If we're talking about straight lines, yes, always.
But I think they were after more, weren't they?
Mm-hmm.
So again, all of these ones, these angles, equal.
Yep.
Opposite angles are always equal because we're dealing with straight lines, and both angles put together make 180. So the relationship of the angles, that still works, and we've got 180 when you add the next ones up. So this also doesn't work for what Blue Marble wants, because Blue Marble wants them to be more than 180 when you add them up in between. Always. But they always add up to 180 when you add in the opposite side angles to them. The opposite angles are always the same. So there's really is only one way to get around this. And that's to not continue the straight line.
Yeah, Larry and who was F again? I can't remember. But they couldn't be on that straight line, right?
Jeff, right? Yeah, this we have to start putting people on the circle. We have to start actually
Yeah. Yeah, so there's
doing
Jesse.
this.
Yeah.
There's Jeff, right? Now, we can't put straight lines. We can only have segments for measuring angles. And these ones can be lines, obviously. This one can be a line and this one can be a line. Now, I may as well put the points in on that. Point. Obviously, if I delete that line and that line there, so if I start trying to measure angles, like from E to B to D, F, and G, D. Oh, well, how did that one get up there? Angle G, D. And move these. You get all the same angle. Near enough. I have to put these lines back in. Otherwise, these angles don't make any sense, do they? So here's your angles. And this way you can do it. But what you've just give up is the straight line. Extending with the exterior angles. This line can't be there. This is the line that we had earlier, the straight line that goes, the tangent line that we originally started off with. It has to disappear. Can we get rid of it? There you go. No tangent line. Just get rid of it. We don't need it. It's no good. It just makes it look messy. And this is what we're dealing with, I think. This is the blue marble science proof of there being no straight lines, no parallel lines. Because, I mean, you can get this and make a parallel line. Is there a parallel line thing? Parallel line. Can we have a parallel line to that? What's parallel line? You can put it anywhere. You can have parallel lines. You can have another parallel line to this one. Let's have this. This one deserves a parallel line as well. So the parallel lines are definitely possible. But what I think these guys are trying to say, Blue Marble, in a very tricky way, is that it's not really possible, because it is possible for you to have parallel lines. I don't know, what's he trying to say? Does anyone know what Blue Marble's trying to say using proposition 29?
I think that he is trying to say that this proposition doesn't apply to his example, because otherwise it doesn't make any sense.
Yeah, he's just trying to say that the parallel proposition 29 does work. It is a proof of parallel lines. But I think Blue Marble's saying if you draw a circle and use the lines at the center point, that you will always get more than 180 degrees when you add these two angles together. Right? Because I guess you could put a point here, like say here and here, and you could draw a line between them, and this angle here, let's see if we can measure them. This angle here, and this angle here, and this angle here, and this one, when you add these two together, you get more than 180.
Yes, because between 2 points, these original points, A and B, there is a straight line. And then you can use that proposition. But if you dissect this line into 2 at an angle, then of course you cannot use that proposition.
Yeah, if you extend the straight line, then you'll find out that they do add up to 180. But if you don't extend the straight line,
Yes, he's just creating additional
if you just
angle.
have a segment from here to here, providing this line isn't straight and you do a line from here to here, then these angles will always add up to more than 180. But if you continue this straight line, then they would be 180. Right? Because it's a straight line. The difference between that one and that one is going to be this amount of angle, isn't it?
Yes, but he is creating angle not between right, let's say vertical and middle vertical. He is creating angle between left and right, so-called verticals. That's the problem. He should use angles between right and middle and left. But instead of that, he's creating angle, this additional angle between most right and most left vertical. So he is ignoring this measurement in the hump, let's say. But he should. If he is using this proposition 29, he should use angle between, let's say, right and middle, always referring to middle, but he is not doing that. He is just ignoring this middle vertical. And then he's just creating 2 separate instances using this proposition. And then he is adding these 2 separate examples into one and adding this angle. I think that this is what he is doing. Because if you add angles between right and middle separately and left and middle separately, then these angles would add to 180 degree. But if you ignore this middle, so then you are creating more. But it doesn't make any sense because they are, yes, these measurements are not correct, because it should be between, always you should involve middle. And he's ignoring that, I think.
He's taking some angles that he knows will always add up to more than 180 and ignoring the ones that when you add them up always add up to 180. It purposely blind spotting himself to the rest of the angles. Particularly, I think the one that's getting him the most is the fact that the proposition he uses adds the extra angle on at the end. So he can't pretend that this part of the straight line doesn't exist with the angles, because that's what he has to do. The angle that he's proposing in proposition 29 states the opposite side of the exterior angles. Well, doesn't have the opposite side. The opposite side is a different line.
Yes, that's the point. He's
Yeah.
making opposite angle to different line. Or yes,
And the very proposition he stated uses the external part of the angle.
So
I've
he's saying
noticed
that
Charles is in here, is he?
so he's saying that this side angles are opposite, but yes, they are opposite, but to different lines. And it has to be to the same line, like in proposition. But he is inclining one of these lines, adding an angle, and he is saying that this is proposition. No, proposition is about one line cutting two parallel lines, or whatever. Cutting two lines, one line cutting two other lines,
and using the external angles. Well,
yes,
that's not what Jesse's doing.
No, they are creating two different lines.
So what they should do for Jesse to be to prove what he's doing is he should measure the opposite angle too. At each of them, instead of them just measuring the internal angle. Let me get another one, another point. We'll have another one over here because this is line. Another point. Yeah. And a segment from here to here. And we'll put another point up here. Right, so here we go. We've got these. We've got all of these angles here now. We're going to put Jesse here at H. Now, he's measuring an angle. EHI, and you've got Larry measuring FIH. With these so we can see 91 and 102. Now, if they were to turn round as well and measure the angle on the other side, which I don't know whether they have done or not, they would also measure these angles, and when you add these angles up, (99) and 91, that's more than 180. This angle 91, 102, it's more than 180. 102, 108, again more than 180. See, every time you add the angles together, you end up with more than 180. And what that does, that tells you that you're not dealing with straight lines. The opposite angle, the external angle, will always add up to more than 180 when coupled with the internal. Both external angles of this line, when added together, will always add up to more than 180. That's what Jesse and Larry don't tell you. Always add up to more than 180, even their own angles. Not just getting this guy to add one to this guy that's measured here. If this guy was to measure this way and then turn round and measure this way, it would also measure more than 180, which goes to show you it's not a straight line. Everyone get that?
Yes, this is just bendizontal, but
it's not.
divided...
It's just dishonesty, and Blue Marble's chosen the wrong proposition, hasn't he?
Yeah, because he's using two different lines, and these two lines are already already have angle, inclination to each other. So it means that this is not one straight line. And he should use one straight line for that, not two different at an angle.
See,
So,
also the problem is, let's see what the angle would be. This here, this angle to this angle, this angle, no, sorry. This angle to this angle. This one, this one, this one. And this one. All of these ones, when you add them together, guess what? That's right. They're less than 180. The complementary angles are always less than 180. Isn't that weird? Because these ones are above 180. These ones, because these ones at either side of the line add up to exactly 180. Because this is a straight line. So the 180 relationship works around the straight line. Hope Blue Marble can see this. And Charles. Charles around here.
He's in the live chat.
Yeah. Less than on the one that's underneath and more than on the one that's on top. But if you use a straight line, and when you add the two together, exactly 180. Isn't that weird? It's not weird at all, is it? Because it's just geometry. It's what we call Euclidean geometry. It's based around the straight line. Straight line has two right angles. Straight lines have, let's say, 180 degrees, although strictly in a Euclidean sense, they don't. Because there is no angle to a straight line. You need the inclination of two straight lines, one to another, in order to form an angle, strictly speaking, in Euclidean sense. That's one of the things that people don't really seem to stick to, do they? The ones on the top, the ones that are claimed that Jesse Kozlowski measures, should be the same on both sides. Wonder whether Larry and that could actually do that, because that'd be impressive, wouldn't it? Going and measuring more than 180 degrees everywhere you go. When you go and you turn around, right, to do the opposite side, the exterior angle, like Blue Marble says in his proposition 29. Because I think what you'd be able to do there, if he did that and actually turn around to face the opposite direction, I think he could prove that it's not actually a straight line that they're measuring. Always a drop. So let's see what he says. Charles says, hello. You're confusing the issue by crossing two straight lines and discussing the four angles. They will, by definition, sum to 360. And any consecutive pair of them will sum to 180. And the vertical angles, the opposite ones to the vertex, will be congruent. That's not proposition 29, though. It is. It definitely is.
This is from a geometry teacher.
Yeah, Proposition
Yeah,
29,
Jesus.
Charles, is the one that uses the exterior angles. So, say you're crossing two straight lines, it's using the exterior angles. So, you should be crossing two straight lines because that's what it's talking about. I showed you at the beginning. Parallels.
Yes, but in blue marble science is crossing these two lines with two lines, not one. And proposition is talking about one line crossing two lines, not two lines crossing two lines. So, yes, that's why I would say that he's not using. He's saying that he will go to use this proposition, but in fact, what he's doing by measuring angles in that way that he is doing, yes, he's just invalidating his usage of proposition. So he's abusing, let's say, this proposition.
Yeah. Yeah, it's good to see that Charles knows that 180 degrees. But as you can see, Blue Marble dishonestly used two angles when you add them together that don't add to 180, whilst purposely disregarding the part that would show that they do actually add up to 180 by saying you're crossing two straight lines. Charles.
So in fact, he's not measuring or calculating external angles from the same line, but from two different
I'm going to have
lines.
to put this on so everybody can see that this honest twat's doing. Discord, there you go. So this is Charles. He's saying Proposition 29 does not concern the four angles resulting from crossing two straight lines. Let me go and get the link again, just so everyone can see how far away it was. There it is. Proposition 29 states, oh, can't really see. If a straight line fall on two parallel straight lines, it makes the alternate angles equal to one another and the exterior angle equal to the interior. Charles. It does use the exterior angles. So, yes, it does use the four angles because Charles says here, Proposition 29 does not concern the four angles resulting from crossing two straight lines. I'll put it out again. And the exterior angle equal to the interior and opposite angle, Charles. Proposition 29 does use all four angles, the interior and exterior. You lying shit, Charles.
And you could tell because of what Euclid writes below. Let the straight line EF fall on the two parallel lines, straight lines AB and CD. The alternate angles, he gives 1, AGH, 2, GHD, 3, EGB, and EGB is shall be equal to the interior and opposite angle on the same side. That's 4 fucking angles, Charles. You're either purposely stupid or purposely dishonest. I'm not sure which.
Mm-hmm.
I go for the latter.
Yeah. Definitely lying shit, I'd say, Charles. As Mike Jones pointing out, just exactly how dishonest you are, Charles. Claiming
this
to
is
be
what
a
they do.
fucking geometry
Yeah,
teacher.
exactly. If he is, this is the kind of dishonesty he teaches children.
Mm-hmm.
You could tell the kind of person this is. Make your own judgments. But he's a super honest person, though. That's what he says.
Yeah. Tempted to call him a slimy shitbag. But he's going to do it tomorrow. Blue Marble Science. Did you everyone see that?
It'll be great.
Oh, yeah.
Tomorrow.
I'll put this out. We will be going a little bit early tomorrow because you're about to get owned, Bev. Pwned from Blue Marble Science. That's me. That's Flat Earth Math. Charles.
Try to wiggle yourself out of what's coming.
This statement of Blue Marble Science is about what exactly? So
he's going live tomorrow night. We're doing a watch along. Charles, Flat Earth Math. Charles is going to go and have a word with Blue Marble Science tomorrow.
Okay, you said that a bit earlier. How much bit earlier? Because I am not sure if I can.
9 o'clock tomorrow. So like 1 hour after we normally start, they will be doing a live stream.
Oh, okay.
So I think I'm going to start perhaps 7 live. We'll do 7 till 9, then stop and do the watch along party over on the level server. We'll watch Charles and Blue Marble Science have their first lads get together on this month of all months. Charles is about to be dishonest, so can we just go over this? Charles says, again, you're not paying attention to the details. Yes, we are, Charles. I've just gone over it. The exterior angles also. He says, when you cross 2 parallel lines with a transversal, 4 angles are formed. An earlier proposition covers crossing only 2 lines and the angle relationships. Proposition 29 concerns the relationship between the angles that don't share a vertex. Yeah, they're parallel lines, Charles.
But they still create 4 angles. It doesn't matter.
As in, you always could make 4 angles when you cross 2 straight lines, Charles.
Yeah, at any angle.
And the reference explanation discusses 4 angles.
Yes, Charles, we do know. And we do know the earlier propositions. That's exactly why I said, why didn't Blue use the earlier propositions, the ones that doesn't use the exterior? Because the exterior shows that straight lines have 180 degrees. Blue Marble wants to end up with more than 180 degrees. The only way you can do that is to not have straight lines. You just have to use segments.
Yes, and he's declining segments.
Mm-hmm.
So he is creating, in fact, 2 straight lines already being at an angle to each other. So this proposition doesn't apply anymore.
Yeah, that's terrible, Charles.
I just got off like a 40-minute phone call. I'm sorry.
No problem. Stark Odders,
Still with this
I
one.
don't know.
Again.
Stark
How many
Odder, I mean,
times?
stop trying to take the fame off everybody else. This is flat earth math and blue marble science, right? Leave your stupid shit behind. Just for a moment. We'll come back to it at some other point. Right now, we're on about Proposition 29 and blue marble science trying to falsify Euclid. He doesn't realise it yet. Horizontal planes. Straight lines, Charles. Straight lines and planes are defined in Euclid.
And they can have any orientation. So orientation does not require definition.
Not within Euclid, definitely not. Nothing to do with geometry at all. But you can orientate a straight line vertically.
Yeah, plumb line. Yeah.
Well, you could take all of the geometric principles that you've got, any one of the straight lines within Euclidean geometry, you could orientate it vertically. Like if you would have a square, right, you could choose one side of that square and orientate it vertically. You could definitely do that. Now, the question is, what about the opposite side to that square that you've just orientated vertically? What would everybody else say? Would the two sides that would be perpendicular to that one side that's now vertical, would they be horizontal, for instance?
Yes, but
and the other side that's perpendicular to the two horizontals, would that be vertical?
That would be, but in example, blue marbles example, you cannot even create these squares anymore.
You mean blue marble in his Proposition 29 has falsified the ability of you making a square and orientating one side vertically?
Like adjacent squares, one to another. You cannot do that because you are just would create some kind of trapezoid or whatever. But
let's
that
see.
would be not.
Let's check it out. If we have a perpendicular line here and here, and then a perpendicular line here, perpendicular line here, perpendicular line here. It's looking a bit of a mess, isn't it? All of these squares look like they're wrapping over each other. So this is what happens whenever you make a square with Jesse and Larry's straight lines. It looks a mess. I don't like this sort of stuff. Even this looks messy. Doesn't look like you can actually use any Euclidean geometry with it. Don't give him the fame, Mike. He's trying to steal flat Earth math and blue marble and the Proposition 29. Because they were parallel horizontal planes that he's got in his drawing. Blue Marble's not having them. Earth isn't a plane. I don't know who said it was. Who's that in? That's that bendy straight line guy. Has somebody been telling him Earth's a plane? Somebody been saying Earth's a plane? It's not
I
a plane.
don't know. But he did say that he did type the words straight curved line.
Did he?
Yes.
Yeah, this guy.
He actually typed that straight curved line together.
And-
All
And-
three of those words together.
And
Yeah.
he said that when he was in voice chat.
Yeah,
So-
he said that. Yeah, he did say that when he came in the other day.
And this line is conforming to environment. So this is also a great statement. Yeah. So the environment for straight line is air. So air is curving a straight line. So doesn't make any sense for me, but okay, this is 2023. Yeah. So air is bending straight line. Good.
Well, not technically.
I am saying what I'm repeating what he's saying. This is implication because he said that line is conforming to environment. So in order to establish horizontal, we have to do that. We are doing this in space, and this space is filled with air. It means that air is curving straight lines. So it doesn't make any sense, but this is his logic.
Built a road that follows a longitude line, you'll have a straight curved line. It's that easy enough to follow. I'll do it in a minute. Straight curved line, is he? Are these people all right? I mean, we are just talking about Euclid, right?
Yep. And no, they're not all right.
Is that what Blue Marble's done with Proposition 29? Why do they have to start talking about straight curved lines? I mean, that just doesn't make any fucking sense.
Yeah, this is contradiction in terms. So you cannot predicate upon line to be straight and curved at the same time. So this is just contradiction in terms or in adjective. So
Start from the monad. How do you start from how incarnation? If you're listening, how do you start from there without just imagining it?
yes, I have a request. Please draw us straight curved line in chat, in live chat. If you can post straight curved line, please.
Don't understand how plums work. Wow. Yes, we do. Incarnation. Don't think there's anybody else that's studied it more than we have. Not that it really needs studying, but for fun we did it. To prove that we could. I challenge anyone to have done it any more. Anyone.
I don't know if this is worth reading out or just to point out some model affliction, but this is funny.
What have we got?
I would suggest that this is implicit admission that he actually has no clue about geometry. That's what I want to underscore with this.
Who's this incarnation?
Yeah, that's the
Yeah.
question.
You don't understand. Yes, yes. We know that phrase. Yes. We don't understand curved straight lines. Yes, we don't.
Law of identity violation.
Absolutely.
Stark Odder is trying to take all of the limelight off them, Stark. Don't worry about it. Blue Marble and Flat Earth Math got themselves here. You've been saying that stupid shit for as long as we can. We try and ignore you, really, because it's just like some child sort of pulling the pants, you know, like pulling the leg of your pants. And we have to keep saying, Stark, stop being so fucking ridiculous. Stark Odder's proposition really is that if he can measure spherical excess, i.e., if triangles have more than 180 degrees, therefore verticals cannot be parallel. Which is sort of similar to what Jesse and Larry have handed to Blue Marble, right? The more than 180 degrees.
It's a modus tollens, isn't
Yeah.
it? Triangles do have 180 degrees, aka not more.
Yeah.
Hence, according to him, verticals must be parallel.
Yeah.
Yes, but still it is non sequitur.
Oh, for
Because
sure, yes.
Yeah,
it
it's
doesn't
just like
imply-
Betty with his ridiculous, but if they set it up, then you can surely, other than saying it's a non sequitur, you can also show them how easy it is to defeat that and point out that they're setting themselves up for a fall within their own logic.
Yes, and non sequitur is because if you draw this so-called triangle on the surface of some ball, and you are still hanging two plumb bobs on your whiteboard, you can't draw this figure, strange figure on your ball, and your plumb bobs on your whiteboard will not deviate. So that's why it is non sequitur.
Okay, thanks, Saragaki. Catch you later. Mike, you keep doing it. You're giving Stark Odder all the limelight. It's not about Stark Odder being his stupid fucking logical statements, triangles, parallel horizontals. Thinking he can measure more than 180 degrees. He does. He seriously thinks those angles are more than 180 degrees. It's all about Blue Marble, and he's more than 180 degrees. You shouldn't let Stark Odder come and take his limelight off him. Leave it to Blue, Stark. What are they talking about? This is getting serious. Does anybody know who I either... Because Incarnation, I've never heard of him before. Been around here doing this, talking to people about level, doing tests and all of that. And all of a sudden, just some random dude decides to come in and start shouting that straight lines have more than 180 degrees. Triangles have more than 180 degrees. They're mad.
Yeah, they are just asking the same question, so they are repeating this whole process. We went that through that mm, for now, I think, few years, but some people are just starting, so they are just asking questions from like 6 years ago.
Yeah, they're coming with a 2018 arguments, aren't they? Like they're
Yeah.
brand new. Like I've just no, it's like no, we've had this all along. They just say triangles have more than 180 degrees. Like it's impossible. Can't do that. They don't know the fundamentals. They don't know the semicircle. Triangle cast within a semicircle will always give you a right angle at the point of tangency every time. So flat earth math says in Cartesian coordinate system, thanks Descartes, verticals are always parallel, at least in the Cartesian coordinate system, as are horizontals. They're all parallel within the Cartesian coordinate system. Thank you, Descartes. It's his birthday today.
Yes, so graph
Graph
using
paper. Yeah.
so it means that elevation profiles and maps and plans are using Cartesian coordinate system. So there is no space for any curved involved in elevation profiles. So this horizontal line, which seems to be straight on graph, is really straight.
It is actually straight, yeah.
Yeah, because they are using this coordinate system, not other.
Also, the idea that because of the coordinate system, the horizontals, they have no change in elevation. If the horizontal line is on the 0 on the y-axis, right? If it's on 0, then no matter how long you extend it, it will always be on the 0 on the y-axis, the vertical. It won't gain any y value just because you go further away.
Yes, so this is possible only when this line is straight and perpendicular to vertical.
I.e. Cartesian coordinates system.
Absolutely.
Yes.
If it is curving, it would be gain or loss of altitude on vertical datum.
Or if it was sloping, you would have the rise over the run and you would be able to measure the change in the vertical axis elevation. In reality, that's what elevation is measured on the vertical axis, and it's obviously reference to the Cartesian coordinate system. In reality, I don't think there's any surveyors that use anything other than the Cartesian coordinate system. Are anyone aware of surveyors or anybody, builders, architects? They all use the Cartesian coordinate system, don't they? Every one of them.
I'm not specialist, but as far as I know, yes, only
mathematics, computers. Can you think of anybody that wouldn't use the Cartesian coordinate system? They do it in mathematics in schools. They use the Cartesian coordinate system, like Charles said, all graph paper, Cartesian.
I would even say in computer games, especially. But I'm not specialist. But I would say yes, also there, because how could you do any mapping of these realms, positions of objects, etc., on the map in 3D, let's say map, you have to have this this coordinate system, Cartesian, I mean.
So I think Mike's pointing out to Charles that he's saying about orientating the XY graph paper in a horizontal or vertical orientation. And he's saying, I don't think he can, or he's not admitting to be able to orientate any graph paper with the Cartesian coordinate system, either vertically or horizontally. We don't know. Just on the paper, but you can't orientate the paper either horizontal or vertically. So could you orientate one of the lines of graph paper vertically, Charles? And would the perpendicular relationship continue throughout the graph paper? Yeah, that's what I thought, Mike. Yeah, it's tricky, isn't it? Could you put like one corner of the graph along a vertical? Could you, Charles, could you orientate the paper on a table horizontally? And would that match that square system, the X and the Y? Because that's what I say. In reality, the X and the Y is the horizontal plane. And then you have all of the perpendiculars to that being vertical on the Z. Other people do it differently, but I do. So if you lay the graph paper, X and Y, could you say that's the horizontal plane and your orientation of Y? You could say, put it on the azimuth, point that Y axis to north. Then all of the squares would be orientated east, west, and south along those axes of the verticals. Y and the X being the horizontal plane. You could then put verticals to that horizontal plane, perpendiculars. It's tough, isn't it? Flat Earth mathematicians having problems with orientations. It was Charles that had the problem with the orientation at the first time, right? He did get upset at us doing stuff.
Ev,
Hello.
hello. See that guy in there, that guy that's talking to me? He's literally having conniptions over me saying that verticals on a circle would still be parallel. Well, they are. It's radials that aren't parallel. Like I can draw, 4 vertical lines over the top of a circle. They'll still all be vertical and they'll be parallel.
Well, you're using the graph system that he's using. You're using Cartesian coordinate system type stuff.
Yeah, he's using all 3D Cartesian coordinates, Euclidean geometry, but he's basically saying that verticals on a sphere are not parallel because they're actually the radial lines. And he's laughing his guts out at the fact that I said verticals can still be parallel on a circle, on a globe.
Yeah, well, we have actually stopped saying that, right? It should be the enthymeme. You should leave that. It's far too upsetting
Yeah.
for them to hear that. So, I mean,
if they,
go on.
I don't mind if they want to change what they call a radial and say it's now a vertical, fine. But you need to understand the implications that come with that. You can't then just use your radial lines exactly like a vertical. They're not the same. They're tilted from. You guys are absolutely insane.
It's a radius or an extension of a radius beyond the circumference. I don't even know what the word for that is. Like, do you know? Does anybody know here? In
The word
geometry, yeah. Well, you know what a radius is, right?
Yeah.
Well, what do you call a radius that goes beyond the circumference? What is there a name for that word? For that thing?
A big pie?
Radial line or whatever. So,
but a radius is a radial as well, isn't it?
yes. But radial, it means that it is from the center of the circle, and it may go beyond, but it have this property, let's say, direction from the center to outside.
Yeah, but they're talking about on the other side of the circumference, right? Like, it has to be on the other side of the circumference. This for
yes,
but I don't think there's a word, is there? Like a chord
line
segment.
through. I would say that this is chord line cutting circle through the center, like diameter, but extended, of course. So this is not diameter, because diameter is from circumference to circumference.
Yeah, it's the extension. It's the other part of it on the outside of the circle. Yeah. Is there a word for it? Don't think there is there? Because it's not part of the circle.
No, of course.
So there isn't actually a word for what they're trying to call vertical, where there is an actual vertical in reality. They're just trying to get you to associate the vertical in reality to the thing that there is no word for in geometry. Aren't they? That's why you're having problems talking about it. You're talking about radials, but that's just a radius. Something extending from the center, but the monad doesn't exist. Talking about a fantasy, you're talking about things that don't exist just to enable the people that you're talking to. It's their fantasy. I don't know why anybody gets involved in it. I know what a vertical is in reality. I don't need to get involved in anybody else's bullshit. Imagine it not as it is. I can't see the point in it. We've just got a load of people that want to come round here and want you to be able to imagine plumb-line tilt. And then they want to try and give you some excuse as to why you should capitulate to their fantasies. It's a very strange group of people, telling you. And I know they have to have it happen, and that's fine. The reason that they have to come here and tell us that circles have verticals, which they don't. Circles don't have verticals. It's really weird that people like flat earth math want to come in and tell you there is no vertical in geometry, yet the extension of a radius beyond the circumference of which there is no word in geometry, he wants to call that vertical.
Yes, new speech. Yeah.
At the same time telling you that there is no definition of vertical in geometry. Divergence of verticals. You do realise nobody has ever measured that, Charles. It's impossible to be able to measure that. And what I think you're trying to say is you can measure the slope of a horizontal.
And by the way, you cannot demonstrate diverging plumes at large distances. So this sentence doesn't make any sense.
Yeah.
Because he is using word demonstrate. How? So in physics, so that would be physical demonstration. And Charles said before many times that this is practically impossible. So in physical world, it is practically impossible to demonstrate plumes diverging at large distances. And now he's saying that reciprocal zenith angles demonstrate something. No, they don't.
So vertical is synonymous with plumb. Charles is saying that. Vertical is perpendicular to horizontal, and plumb is perpendicular to level. Charles, that's a relationship you can make. Both things being similar to each other. Similar relationship. Yes, Charles. We know that you can make more than 180 degrees. Yes, we know that. We just want you to understand that more than 180 degrees does not make triangles have more than 180 degrees. It does not make a straight line have more than 180 degrees. It does not make the horizontal distance from A to B longer than some other distance. There's no shorter distance than a horizontal distance from A to B, Charles. You can't start redefining how straight lines are geometrically. It's ridiculous. But don't worry, the real globe is still real. It's not going to disappear, Charles. There's no fear.
And by the way, he's saying that using proposition 29 and the reciprocal zenith angles, you can see the two lines are not actually parallel since the angles sum to slightly more than 180 degrees. It is not true because in that proposition, we are cutting two lines with one line and not two lines in angles to each other. So if you are cutting these two lines with two lines being at an angle to each other, then you are not using proposition 29 because proposition 29 is about cutting a line with one line. About cutting two lines with one line, one straight line, not curved line and not inclined line. So with angle in between these two lines. No, one straight line.
Stark Otter thinks he's corrected me. Stark, triangles do not have more than 180 degrees. See, the problem here is Flat Earth Math saying it's not about triangles having more than 180, yet Stark Otter's there saying that triangles having more than 180 is what makes verticals not being parallel. So Stark Otter is trying to tell us that triangles do have more than 180 degrees. And by extension, straight lines have more than 180 degrees. And Flat Earth Math isn't realising that that's actually the game that's being played. He might be as oblivious to what's going on as Blue Marble Science. Flat Earth Math. There's certain people that know what's going on, and there's certain people that don't. They're oblivious to it. Here's the trick, right? Why do you need non-Euclidean geometry?
There is nothing like non-Euclidean geometry. So
Why do you need non-Euclidean? Why do these guys want to imagine non-Euclidean geometry?
to justify their model only, but
Because parallel lines.
parallel and perpendicular.
You
Because
need to be able to have a triangle form with more than 180 degrees. Right?
Yeah.
Otherwise, you've got parallel lines, and you can't have parallel lines. So you need a triangle to be able to form with more than 180 degrees. Now, you do that by making triangles have more than 180 degrees. You do that in non-Euclidean geometry, right? But what Flat Earth Math and Blue Marble Science are doing, they're making their model without needing non-Euclidean geometry. So if Blue Marble and Flat Earth Math are correct, there's no need for non-Euclidean geometry at all. You can make their model with Euclidean geometry. But he doesn't seem to realise that he's trying to make triangles with more than 180 degrees. Jesse has got them to try and make triangles with more than 180 degrees. Stark Otter's playing the game that Jesse's done. The little bit of wizardry. I'm not too sure Flat Earth Math and Blue Marble Science are aware of what's going on, and they're just going to be oblivious to it. It's a little bit technical, and it's awfully confusing because it's not real. It's just people fucking with you. And those people are people like Flat Earth Math, Charles, and Blue Marble Science, Stark Otter. Whoever this new guy is, not got a clue who he is, but I don't know whether he knows what he's getting involved in. Stark Otter and Flat Earth Math's going to do psychological puzzle. Nice.
I don't use psychology studying logic. So sorry, it doesn't apply to Euclid.
Stark Otter's doing his proof again. And that proof says that triangles have more than 180 degrees. Flat Earth Math is unaware that Stark Otter's providing a proof he thinks that triangles have more than 180 degrees. Flat Earth Math can't see it. And he's still talking about non-Euclidean geometry again. It's so confusing, and it's no wonder that people are fucked in this arena.
No, on the surface of a curved sphere. This is just beautiful. Can we have not curved sphere? So why
Yeah.
he is adding curved sphere? Just sphere. We know that sphere is curved. Yes.
Constantly curving, yeah.
Yeah.
The only part of a sphere that isn't curving is the radius or the diameter. They're straight. But they're Euclidean. That's the Euclidean part of the sphere.
Yeah. And this line is straight. Really straight.
Jesse measured the bridge with the X, Y, Z coordinates in 3D space with GPS. Jesse measured the bridge with X, Y, Z coordinates. 5.8, 5.8, 5.8, 5.8. All the way across. That's a straight line in X, Y, Z coordinates, Charles.
Yes. No curvature.
Everyone can see that. Just so we can see X, Y, Z coordinates in 3D space. Jesse measured the bridge with X, Y, Z coordinates in 3D space. He curved it afterwards.
Yeah. They are curving horizontal. They have, for example, elevation profile with normal horizontal, and then they are curving this horizontal, and they are saying that yes, on the graph we can see straight line, but in fact this straight line is not straight because they are just making it straight for visual or whatever, but really they are not straight. This is what Blue Marble is saying about elevation profiles, which is nonsense, of course, but this is what he's saying. So yes, afterwards, they are measuring normally, normal triangles, normal straight lines, and then they are starting to curve it, to model it on some computer graphics or whatever, even like Jesse Kozłowski. But
No, they just made a model.
yeah.
They made a model afterwards. They didn't map anything. They just made a model to fit a picture.
Yeah. So yes, that would be that. So they are curving straight lines because only in calculation in computer graphics. So not in elevation graphics or whatever. No. I am saying about computer. What he, for example, Jesse Kozłowski was doing with his computer. So he
Look, he's
curved
going.
this.
He's saying flat Earth math. Now he's saying the 5.8 isn't the XYZ coordinates, even though that's what he's just said, that Jesse measured the bridge with the XYZ coordinates.
Yes, he's contradicting himself.
Yeah. Flat Earth math. I mean, isn't it important? Or wouldn't it be good if Jesse Kozlowski were actually around here to answer for all of the bullshit he's been talking about? Instead of having somebody who obviously knows nothing about it, a guy called Flat Earth Math, obviously, talking about the XYZ coordinates, but then saying that the elevations weren't on the XYZ coordinates for some reason. XYZ coordinates. Cartesian, it's his fucking birthday. Vertical is a geometric term that indicates up and down. It's axiomatic. Why do you deny this? Because it's false, says Starkodder. because it's false. He says up, down, vertical, horizontal, etc. are physical concepts in reality that don't exist in geometry.
Because you don't need orientation in geometry, but you can apply geometry in orientation. So this is no problem. It doesn't
Cartesian
change
coordinate
geometry.
system.
Yeah, so orientation of this coordinate system, which is based on perpendicularity, you can apply to plumb bob and horizontal, and you can use geometry. So when you can say that these lines are perpendicular, you know that these lines are perpendicular, and you can name one horizontal, and then you can name other vertical, relating them to orientation. So this is no problem.
I've got a question for him. Right? If the bridge that was 5.8 meters going all the way across, and if that wasn't an elevation, why did Blue Marble say there's 110-foot difference from one end to the other?
Yes, if they are implying this elevation from a circle or whatever, so that would be no elevation change. But he's saying that there is. So from what this change was measured? This is question.
Blue Marble says from one end of the bridge to the other, there is a difference of 110 feet.
Okay, but it means that he was taking a line from A to B, straight line, and he measured somehow hump in the middle.
Whilst measuring at 5.8 elevation across the water, there's a 90-foot hump and a difference of 110 foot from one end to the other in elevation, according to Blue Marble, although they all stayed at 5.8.
Yes, it means this is a perfect circular reasoning, because he is saying that he is measuring this hump, and this hump you can measure only from straight line, this chord line in his diagram. But then he's saying that this hump is not a hump because there is no elevation change, because we assume a level being curved. So this is circular reasoning, because if he is trying to prove, and he is trying to prove, that level is curved, this is his claim. So he is assuming already that level is curved, if he is saying that there is no elevation change, because from straight line there is elevation change. So if he's saying that there is no elevation change, it means that he is assuming curved level. If he is assuming curved level, he cannot prove curved level, because you cannot prove anything with circular reasoning. Simple. Okay, I have to go to bed because I have had a very hard day today. Good night.
Oh, sorry, I was muted, wasn't I? Okay, so what we've got here is a picture of blue marbles. I don't think he's copyrighted this one. But you can see it's got distance from the origin, and the difference of from one end to the other seems to be about 110 foot. Is that all right with everyone? That was blue marble, Charles. It was blue marble that did it, that drew those lines. Like, none of it represents reality. It's just a drawing. But you can definitely see there's a difference. Can everyone see that? A difference of 110 foot. From one end to the other. Now, it does seem like this one goes up, but it's lower than this one over here. It's not quite as far. So this one, according to this, is higher than this one here, or this one does look like higher. But this is the lowest. Now, when Jesse Kozlowski got in his car and drove across the bridge, right, he noticed that it was 5.8 meters above the water constantly, all the way across. But Blue Marble Science seems to think that there's a 110 foot change in it from this side to this side, and there's a 90 foot hump in the middle.
Based on what?
Based on some numbers that he's drawn. Jesse Kozlowski drove over it and did 5.8. Charles is trying to tell us that the 5.8 is elevation, but the 110 foot difference from one end to the other, that's not elevation.
What's the difference? How do you differentiate? An assumption? I don't know.
I don't know. Not got a clue. He's still got his problem with horizontal and vertical being perpendicular. You know, and plumb and level being perpendicular. Charles doesn't seem to know, like, in reality. I think he's led a sheltered life, and he likes to claim he's a teacher, but I'd say he's a student, because he's not learned anything. He's definitely not capable of teaching. Absolutely not anything to do with surveying, practical geometry in reality. Seems to have a massive problem with it. He thinks horizontal and vertical aren't scalable because they're straight lines. Doesn't think straight lines are scalable. Plumb isn't 90. Come on, math. Plumb isn't 90. It's just plumb, aka vertical. It's perpendicular. It's a perpendicle. It's literally called a perpendicle, Charles. Terrible. Sort of people is posting it again. This is getting pretty frustrating. Well, I'm going to say frustrating, but I mean, I hope everybody's watching what's happening here. This is Flat Earth guy saying fucking ridiculous shit under the guise of a flat earther. Imagine. I hope people are like wondering what's a flat earther saying stupid shit for?
Where did he say that vertical wasn't 90 degrees?
Just there, plumb isn't 90. It's just plumb.
Isn't this the guy yesterday that asked his professor about vertical to curve? Or is superior? I don't know. Maybe I misremembered that conversation.
Gonna get this. There you go. I've got that one. Post that there. Put it in the other chat. Just so you know. Save it for prosperity. It's always good when we get people to say stupid shit. And the way plumb isn't 90, I mean, of course it is 90, but what's it 90 degrees to? Right, it has to be 90 degrees to something. And normally when you start at 0, that's your base, that's your starting mark. So if vertical is 90, that means you're starting from horizontal. That's your base. They are perpendicular, so it doesn't really matter which is which. But if vertical is 90, then that would seem to say that horizontal is the base that you start from. Not starting from vertical, you start from horizontal. With vertical being plumb and at 90 degrees upright. Look at all of the he's on with his liar thing. Smiley face. What sort of a person calls somebody a liar with a big grin afterwards? What sort of person does that? A guy that calls himself Flat Earth Math. That's why. Who? Flat Earther. I've got a Flat Earther in here saying that plumb isn't 90. Tilting plums. What's up with him? People are going to let this happen as well. I'm going to let it happen. Although, I don't know what I'm doing here. People are just doing some really weird shit. And they're not talking to me, talking to each other. People are just talking in the chat. Nobody's saying anything, just me here. Wondering why everybody else is talking shit. Nobody's actually saying anything. Just all in text. Nervous laughs. Lol. Liar. Smiley faces. It's like it's a fucking game to people. Gaslighting people. Completely. I don't know. What sort of a show do we have? What are we doing here? We're in a platform for people to say stupid shit.
He's literally denying that a line from the middle of a circle out is a radial. He just will not admit that that is what he uses. You'd think he'd get tired of being so wrong, but they don't seem to.
Horizontal and vertical will always be perpendicular, whether they're 100 miles away or not. That's a fact.
But Charles has them being both perpendicular and also not perpendicular, as well as verticals being parallel when we build squares in reality in a vertical orientation, but they're not parallel, really. Like, I'm confused. I don't. No wonder they're confused. My goodness.
Blue Marble
They've just
Science is saying the XYZ that Jesse went over the bridge with, measuring 5.8, wasn't an elevation. It was a director's cut for me saying that Jesse used the XYZ coordinates that Flat Earth Math said, right? So I repeated the XYZ that Flat Earth Math said. Then I said the elevations that he measured were 5.8, which is what Jesse said. And Blue Marble thinks that's a director's cut for him. This arena is fucking ridiculous. Blue Marble thinks he's getting some sort of a win because I repeat what Jesse Kozlowski and Flat Earth Math are talking about. And Blue Marble Science, a fucking boomer, is sat in the chat saying that he's going to make a fucking video about me repeating what they say. They're the ones that are talking about fucking bendy straight lines. And now he's saying Blue Marble. Yes, that's championship stupidity. Repeating anything that any of these fucking ridiculous idiots say is stupid, Blue Marble says. Championshiply stupid if you repeat what these people say. Take that in and then realize what sort of a fucking stupid arena you're in. Idiots. Fucking idiots. For repeating what they say. Is everybody aware of this? And what do you think I've been saying? Vertical and horizontal are perpendicular. Level is a straight line on a horizontal plane. Vertical is plumb. Verticals are planes, as are horizontals. They are all parallel. All of the horizontal planes are parallel to the plane of the horizon. That's what I say. And you've got some fucking weird flat earther coming round here saying stupid shit. And when you repeat that stupid shit, Blue Marble says you're being fucking stupid. Talk about fucking Alice in Wonderland. People have lost their fucking minds. People don't know what up and down is. Don't know how to relate geometry to reality. Vertical and horizontal. What sort of arena does that dickhead think he's in? Because he's not in the same arena that he's been in for 15 years when he's here. I don't know how many times we have to say this. This isn't flat earth. Flat earth math is the flat earther, not us. Everyone's aware of that, right? We all know who the flat earther is here. Flat earth math. Trying to convince us that we're flat. We're not. You're the flat earther. Is the flat earther your mate, Blue? Because that'd make sense. What's everybody fucking doing here? Honestly. Leaving, probably. I hope so. This is ridiculous. People need to start fucking growing up. Charles, you're a flat earther. Don't try and pretend you're not. You are the biggest flat earther here. Nobody gives a shit about the earth here. In this server, We talk about reality, geometry, and logic. We're not flat earthers. You, flat earth math, you're the flat earther. It's in your name. XYZ Cartesian coordinates, Blue. X, Y, Z Cartesian coordinates. It's Descartes' birthday today. He made the Cartesian coordinate system. 3 axes, X, Y, Z, perpendicular to each other, all of them. Everybody understands what it is. Oh, it's ridiculous. Can you imagine a group of dogmaticians just chasing people round, constantly talking about flat earth, this? I've fucking got one. Yes, Charles, I have a copy. It's one of the nicest copies of Euclid I have. It's a pity you don't understand what it is you're dealing with, Charles. I don't like the coloured one. It doesn't help in any way. It might help some people if that's the way you want to do it, but I think there's a better way. It's a better way to learn Euclid, and that's to start at the beginning and learn every step, step by step. Get the fundamentals understood. And then you have a firm footing of what you're doing. Some people think it's straight lines, curve. I think there's a possibility of straight lines curving. But once you've taught Euclid, like you claim to have done, you should know. Straight lines don't curve. It's impossible. You can't have it curving because it'd have to curve the other way, wouldn't it? It's crazy for you to think it. Blue, what are you talking about? What buzzword did I memorize? Not got a clue. He's so triggered with words and stuff, Blue. Are you all right? Jolly good, Charles. So straight lines being straight, when do you curve straight lines? At what stage do you teach your children, the ones that you're teaching your students, at what point do you teach them that straight lines aren't straight? Yeah, that's why he calls himself Flat Earth Math Gizmo. He likes to pretend he's a maths teacher, even though he's never studied mathematics. He likes to pretend he's a geometry teacher because he has people come round to his house to who he helps with geometry. Possibly. We don't know. It's more of a logic textbook, Charles, I'd say. Shouldn't really teach it for geometry's sake. You should teach it for the understanding logic's sake. So straight lines don't curve then, right, Charles? Or do you like to separate Euclidean geometry from geometry? Or not reality? You like to have a switch between straight and reality and straight and geometry, when geometry is just earth measurements, the measurements of the land. You want to pretend that when you are measuring the land, it's not like the geometry that you've been taught that is land measurement. Somehow different. Somehow. Algebra courses. I don't know what you're talking about algebra for. As if algebra is not going to help you, is it? Measuring a distance or something with a straight line. Like, what's the big deal about algebra? What are you talking about? Blue. Cartesian coordinates. It's Descartes' birthday today. He was the guy that did Cartesian coordinates. That's why we're talking about Cartesian coordinates, Blue. It's Descartes' birthday. So, sorry, Blue, if we're doing a show about Descartes' birthday and mentioning Cartesian coordinates. It might be upsetting to you, Blue. Yes, we know. The axis being perpendicular with each other, X, Y, Z, might be a little bit upsetting for you. But unfortunately, that's the show that we're doing today. To show that there's no elevation change on a horizontal plane. It would be the XY plane that you're dealing with, and the Z would be the vertical. Now, on the horizontal plane, there is zero elevation change. In reality, right, that's on the Cartesian coordinates, XY. You made a very distinct distinction between a straight line and a curved line. We know that. You just want to call it a straight line. You want to call the curved line straight. And that's the problem that we have. I don't see why you should want to call a curved line straight. No matter how great you want to imagine it. It's a circle, not a straight line. Charles, math, flat earth mathematician, Charles. Circles are not straight. Radiuses, diameters, They are straight. Verticals, horizontals, straight. Plumb, level, straight. Circles are not straight. There's nothing wrong with saying that. It's okay. It's okay to say that vertical and plumb are perpendicular to horizontal and level. It's okay to say that all horizontals are parallel. It's fine. All verticals are perpendicular to the plane of the horizon. So it's beginning to sound boring, and I'm getting bored hearing myself say it. I don't see why I would need to talk about something that doesn't exist. Charles, if you would like to read up on imaginometry, think you would understand what my where my position is on not Euclidean, because I have wrote my own non-Euclidean, not Euclidean geometry. And I think it's one of the best, one of the most extensively written, has axioms, postulates, definitions. You'll not find that in any other not Euclidean geometry. You will find it in Euclidean geometry, right? Because that's what I've based my not Euclidean geometry on. But I've made sure it's not Euclidean. There's no similarities with Euclidean geometry at all. So does anyone want to have a look at imaginometry? So we can all have an understanding of what it is. Or should we just end it here? We could come back tomorrow. Plot the raw XYZ data. Is that what they told you, Blue? You not remember about Walter Bisley making his own software modelling? He made his own GPS stuff and everything. It wasn't even invented, all of the shit he made for that. It's complete fiction, Blue. All made up by Walter Bisley. Jesse Kozlowski. The software got wrote by Walter Bisley, at least that's what Jesse said. Could go over that again. Imaginometry, Charles. It's a complete not Euclidean geometry. Like, it's perhaps one of the finest not Euclidean geometries there is. Fully self-explanatory. There aren't entire textbooks and websites, Charles, because there's nothing to be able to understand. You've got a sphere. You want to draw lines on beach balls. You want to put ants on beach balls. You don't need entire textbooks to put ants on beach balls or draw funny faces or whatever on beach balls. I don't know. Race car tracks for ants. Whatever you want to do on beach balls, that's Euclidean. Say the best non-Euclidean, not Euclidean geometry is imaginometry. The diameter isn't defined as the longest chord. It's ridiculous. The sphere is defined with the semicircle. You should have a look. Yeah, just Google it. Google it. Imaginometry. It's right there. You should Google it, imaginometry. Of course you should. If you want to know what a true non-Euclidean geometry looks like, then look no further than imaginometry. As everything you do in reality is Euclidean, imaginometry can never be drawn, depicted, or whatever. Give them some secrets away. Right? You can't ever draw it, because the moment you do draw it, that's Euclidean. Anytime you use any term like a chord or straight or sagitta, that's Euclidean. All of the curves, they're Euclidean too. They have a radius value for the curvature. You can place a tangent, that's Euclidean. Because it's straight, that's definitely Euclidean. In fact, the entirety of Euclidean geometry is based around straight 2 points and the relationship between each other to one another. So, not Euclidean is not straight. Definitely can't use any straights. Which means that you lose circles and pi, squares, triangles. You lose all sense of everything, I think. It's flat enough. Who's that in the chat? Who's what's going on in the YouTube chat? Who's that? Is that a surveyor? We got a really weird situation where we've got a guy pretending to be a teacher called Flat Earth Math, and then we've got another flat earth guy in the YouTube saying he's measuring shit. Like, what's going on? What's the deal? It's not flat, right? Obviously, we know, because we know how to measure elevation changes in reality. We know that. We've been out there watching it. Everybody can watch us doing it. Like, it's a fucking fantasy what's going on here. Sat in the middle of fucking what's going on? What are we doing? Fantasizing? Everyone's fantasizing about whatever they fucking want. Look at it. Talk about crazy. Does anybody want to talk about reality, or is everybody just want to fantasize about bullshit? Who sees all of what? As like I say, I don't know who's talking to who now. What everybody's talking about. Who's talking to who? Is Blue talking to somebody in the chat? Somebody talking to me? Who's talking to what? Flat Earth Charles is talking to somebody else about something else. What's going on? Gonna see it tomorrow anyway. Yeah. Flat Earth Math Charles is going to be appearing live on Blue Marble Sciences channel tomorrow, 9 o'clock UK time. We will be going live at about 7, and then we will be doing a watch party for that very appearance. Although I don't know why or for what fucking reason, to be honest. It's getting slightly fucking ridiculous. I don't know who's talking to who. Nobody seems to what they're talking about. Nobody's triggered about anything unless you're talking to Blue Marble, in which case he's getting pretty triggered. I'll just point out to you guys, right? The Earth isn't level either. Right? It's not flat, it's not level, and it's not horizontal. All we say here is that level is a straight line on a horizontal plane. I don't give a shit about the Earth. Other than knowing, I know how the elevation changes are actually measured. I've done it. And anybody else that's obsessed about the other parts of it, just know I don't give a shit. I just know what it isn't, and know for sure the Earth is not flat. That's one statement I can safely make, and I have been making it fucking ages. Just seems like there's a load of people that like to get each other wound up about a certain thing. I'm not involved in it. I don't give a shit. I don't see why I should be the center of it. So I don't know what's going on. This is just getting fucking ridiculous, to be honest. If you guys, right, if you guys want to fight about whatever you think the Earth is, go to Blue Marble Science Discord. He's going to be doing a show tomorrow with Thingy. Blue, what you should do is you should open yourself up to take all of these questions. My chat isn't the place for it. We were doing a Euclid going over Proposition 29, and you're in here talking shit with people about your dogmatic fucking model. Talking about shit. Go and show people how to do it. Put a picture of me on the front of it. Feel happy about it. Just get a picture of somebody else. Doesn't really matter. Throw a few insults in it. Slander us a bit. Doesn't really matter. I've had enough. It's fucking boring. It's pretty simple. Basic geometry. That's all we do here. And pretty simple basic logic. I think most people are wising up and seeing the fallacies that's going on here. You can see the contradictions. You can see people avoiding the issue. This existential cognitive veiling is done by everybody just to have this fucking stupid, ridiculous argument that isn't even an argument. Flat enough, look, I'm not particularly bothered about the Earth, I've told you. Don't give a shit about it. Like I've always said, I can prove level is horizontal. And that does prove that elevation is measured. It's not flat. No need to get triggered. And there's no need to get triggered about level being horizontal either, because that's fucking true in reality as well. Right. Crazy. Can't keep doing this. Right, join us tomorrow. It's going to be on early. We will be on early. I don't give a shit, Blue. Literally. I haven't got any delicate sensibilities. I just literally don't give a shit about your model, the dogmatic model, the flat earth model, whether you want to think the earth's any particular shape. I don't give a shit. Literally. Don't give a shit. Right, join us tomorrow before the watch party. Should be fun.
Yes, this is basic geometry. Your flat Earth geometry. Flat Earth geometry. This is basic geometry.
It is.
I called you a flat earther,
My name's Ramsey.
insisting that your flat earth geometry will work.
I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with your sad naked caveman eyeball in a bubble of air, you're the reason this species is a failure, and it makes me angry.
Did he say a 5-sided square question mark?
You're a universal horizontal waterer.
You're drunk.
I called you a flat earther.
You want to experience true level? Do you? Yes. You want to experience true level?
That auto level is establishing a horizontal. That's just the way it is.
Because I've done the test with an auto level, which gives you a horizontal.
Yeah, it's gonna look super flat.
All right, come on. Wow, it's so.
Three coplanar points.
Oh Christ! Yeah, true level, bitch.
I called you a flat earther.
If you're into math, there's a certain shape where you could make a 5-sided square.
Are you suggesting that horizontal can't curve?
Oh, everything's crooked. Reality is poison. I want to go back. I hate this.
What's his deal?
Morty. Go to school, Summer. I'll go in Morty's memory and do a little.
Randy, come on, that's a globe. He eventually just gave up and said, yeah, I agree, it's a globe.
Geodesic is a continuous string of infinitely small, straight lines.
Yeah, true level, bitch.
It's pretty flat and level now.
Randy, come on, that's a globe.
Yeah, true level, bitch.
Randy, come on, that's a globe.
Lance to the cosmic slaughter! Well, you seem to be in charge of what I get to remember. Why? Good question.
Randy, come on, that's a globe.
I'll go in Morty's memory and do a little.
Burn right to the ground in pieces. But from the ashes come.
Wow, it's so. Oh my God! Oh Christ! Yeah, true level, bitch.
If you're into math, there's a certain shape where you could make a 5-sided square.
Randy, come on, that's a globe.
Yeah, true level, bitch. Wow, it's so. Oh my God! Oh Christ! Yeah, true level, bitch.
I called you a flat earther.
True level, bitch.
I called you a flat earther.
True level, bitch.
I called you a flat earther.
Yeah, true level, bitch.
Person to think.
When you get to the end of this test and you have a result and you say level is horizontal and everyone says big whoop, that doesn't prove anything about the shape of the earth, will you then say yes it does?
No.
No, okay, I'm going to bed. Right.
Okay, so you.
I'm going to bed.
That level is horizontal is good for you then, right?
I agree. I agree. Level's horizontal. All right,
Sweet.
good night.
True level, bitch.
Perfect.
Wow.
Nice, mate. I came in
Nice.
just for that.